Right, year 7, let's get to it. Put your PlayStation down, put your Xbox down. I know what you really want while you're off school, and that is some lessons on atoms, elements, and compounds, and mixtures, and all those scientific words that you might hear, but you're not yet currently properly able to describe what each one means. I mean, some year 10 pupils, some year 11 pupils I've got, I might say, what's the difference between a molecule and a compound? And they might look at me quite blank because they don't know the answer. Because these are terms that we sometimes take for granted we know what they mean, and we really don't. So the unit all of us in year 7 are going to be doing is this unit here, atoms, elements, and compounds. This is the first lesson you can see on the screen. So let's pull up the learning objectives. What are we going to learn today? And after you've done this little lesson, this video shouldn't take too long, but after it's completed, there are going to be some worksheets which are either linked on the school website or linked in the description of this video or on your class charts. In fact, definitely on your class charts. Check your class charts as well. So what we're going to learn today, we are going to learn to recognize the difference between atoms and molecules. We're going to learn what the difference between those two terms are so we can start using those terms properly. And then we're also going to start looking at the terms element, mixture, and compound as well. And we're going to be using those terms properly. And we're going to be able to give examples of each one. We're going to be able to represent them using diagrams as well and interpret diagrams that have them on. And it shouldn't take too long. Let's have a look. So, what are atoms? Well, you know, if I was to take this pen and I was to chop this pen in half, and then I was to chop it in half again, and chop it in half again, and chop it in half again, and keep going. Eventually I'm going to get to a point where I've got a very, very small bit of pen, haven't I? But how far can I go with that? How far can I keep chopping it and chopping it and chopping it and chopping it and chopping it in half before I can't chop it in half anymore? Well, a famous scientist called Democritus many hundreds of years ago had the same thought, but he had the thought with a piece of cheese, and he cut the cheese. And I know that means Trump if you're an American, all right, but or break wind if you're in England, but he cut the cheese, and he cut it in half, and then half again, and half again, and half again, until he had a tiny piece of cheese, and he wondered, how far could I possibly go before I can't cut it anymore? And he imagined that there was a point that was so small you just couldn't break it up into anything else, that it was non-cuttable. And the ancient Greek for non-cuttable is atomos, and that's where we get the word atom, because we say that an atom is the smallest unit of anything we can get, right? If we start breaking an atom apart, right, if I have an atom of gold and I break that apart, it's no longer gold. If I have an atom of silver and I break that apart, it's no longer silver. So an atom is just the smallest thing I could possibly get of any kind of substance, and it looks like this. We're going to represent them on our diagrams as just little circles, little balls. So here's argon, lots and lots of circles of argon, lots and lots of little atoms of argon, and I can't break them up, right? They're as small as I can go while still being argon, and everything is made of atoms, absolutely everything. So what is an atom, if you're asked? Well, it's the smallest unit of any substance. That's really what it is. It's the building block of all things. All right, I stick lots of atoms together and I get something bigger. So let's have a look at some other examples. Here, this is nitrogen, but you'll notice something here. You'll notice that those circles, they've been put together, they've been stuck together, right? Chemically bonded, chemically joined together perhaps. Now, these molecules of nitrogen are made of more than one atom, and that's really what the word molecule means. Whenever I get more than one atom chemically joined together, I have a molecule. We have loads of different molecules, loads, okay? But molecules are made from atoms, and there's our molecule of nitrogen. And we're going to draw those as just more than one circle, more than one sphere put together. Moving on, we can see the same here with oxygen. I have two atoms of oxygen stuck together, right? Because they are chemically bonded, because they are joined together, it's now a molecule of oxygen. If I was to break them in half, I would have atoms of oxygen. Hopefully, so far, so good. So let's go back to our learning objective. Do we know the difference between atoms and molecules? Well, hopefully in a diagram, you could now identify them quite easily. You're going to look at these and you're going to say, well, they're just one little circle, therefore it's an atom, it's one little unit on its own. But if I start joining them together, I've got a molecule, There we go. We now know the difference between atoms and molecules. Easy peasy, lemon squeezy. So going to the learning objectives, we have some more words here that again we kind of use in everyday life, but do we really know what they mean? So elements, mixtures, compounds. Okay, and this term here, particle diagrams. Well, the particle diagrams are what we've just seen. They're just literally the diagrams of the atoms or the molecules. And we're going to learn to interpret those to see whether something is an element, a mixture, or a compound. So let's crack on with that. Over here I have... Over here I have a slow internet connection, obviously. I'll just whistle while this loads. This is the highlight of this video. This is the best bit, by the way. Okay, so here I have some substances. On the left-hand side, I've got gold. Okay? Now I have many atoms in my gold block. And next to it, I have this substance called lead sulfide. Now, what do we notice about gold and lead sulfide? What do we notice is the difference between them? Well, if I look at the gold, I can point to any one of these individual atoms. And you'll see that they're all the same as each other. They're all just gold atoms. There's nothing else hidden in there that looks any different as far as I can see. They're all just gold. But I look at the lead sulfide and I can see some big grey ones and I can see some little yellow ones. I have different types of atoms. This is where we're going to introduce the terms elements and compounds. So if I look at this on the left-hand side, the gold, if everything is made just of one type of atom, it's an element. Okay, so if I leap across to sulfur over here now, again, if I look in sulfur, I can only see one type of atom, one type of little circle. Right, that is an element. The sulfur there is an element. But if I look to the right here where I see water, it's made of hydrogen and oxygen, we can see red atoms, we can see little grey atoms, different types of atoms joined together. That is a compound. Now, what other word do we think, let's go back to lead sulfide, what other word have we learnt today that lead sulfide also must be? Well, we've learnt the word atom and we've learnt the word molecule. And here, because these atoms are chemically bonded, the lead sulfide is a molecule, right? So not only is it a compound, but it's a molecule. Because a molecule, remember, is more than one atom joined together. And a compound is when those atoms are of different types. They're not all the same. They're not all identical. So lead sulfide, you might be able to guess, we've got a bit of lead in there, we've got a bit of sulfur in there. Water, you might already know, we've got a bit of hydrogen, we've got a bit of oxygen joined together. So they are our compounds, which are also molecules. Let's go back to our learning objective. Okay, do we recognise the difference between atoms and molecules? I sure hope you do, because by now you'll be sick of hearing me say that atoms are just on their own, okay, not chemically bonded to anything else. But a molecule is when we've got two or more atoms joined together, chemically bonded. Elements, well, an element is when all the atoms are the same. There's only one type of atom. Yeah, I chop up my bar of gold and I only end up with gold atoms. Compound over here is when I have a molecule but the atoms are different. Like carbon dioxide, I've got carbon atoms and I've got oxygen atoms joined together. That's going to be a compound. What have I missed out? Mixtures. So let's go back and see if we can have a look at mixtures. Well, let's see what we can define here. I have on the left-hand side, I have molecules. How do I know they are molecules? Well, I know they are molecules because they are made of more than one atom. But they are also elements. You see, when I look here at the red, which I think was our oxygen, then this is a molecule, but it only contains oxygen atoms. So it's a molecule of oxygen, it's an element. When I look here at my nitrogen, that is also an element, but a molecule. But I have two substances in this little bubble here. I have my oxygen and I have my nitrogen, but they are not stuck to each other. Right, so two different substances stuck to each other gives us a compound, but here I've got two different substances not stuck to each other. This is what we call a mixture, right? And I can make a mixture easily. I could take some mixture of Smarties. I could pour some blue ones and some green ones. I could give the tub a shake, and I'd have blue ones next to green ones, but they wouldn't be stuck to each other and bonded. That would be a mixture. This is a mixture here. Whereas if I look to the other side, this little circle here, this is not a mixture. What I have here is a particular compound. It's a molecule, but it's also a compound because the atoms are different. And I can see that every one of the molecules here are the same compound. Doesn't matter what the compound is. Okay, that's not the point of this lesson so far. Just do we recognize this is a compound? So this is not a mixture because I have the same thing. Right, whereas on the left-hand side, I have different things. I have my oxygen, I have my nitrogen, and because they are different, but not joined together, we're going to call that a mixture. So let's just fly through one more time, okay? Our key terms. An atom, the smallest unit that anything can be broken into, the building blocks of all things, those are atom. A molecule, when atoms are stuck together. But in this instance, the molecule is also an element because the atoms we have stuck together are the same. But if I stick atoms together that aren't the same, so for example, the water over here, then it's still a molecule, but now I call it a compound because the atoms are different. They're not the same type of atom, they're different types of atoms, so we call it a compound. A mixture, well, here's a mixture. We have, and yeah, there we go. We have some atoms, we have some molecules that are elements, and we have some molecules that are compounds. So this is actually a mixture of elements and compounds. And we'll get more into that as the next lesson comes out. But essentially, can we tell the difference between an atom, an element, a compound, and a mixture? Can we define those things? Right, now that's pretty much the lesson, but obviously you're going to need some practice at identifying atoms, elements, compounds and mixtures. For that, if you do check your class charts and any other link that you've been told to check, then you should find the information there. Good luck, and I'll be back tomorrow with episode 2. Bye.